66 million years ago, the world ended when the dinosaurs took over. It was a heaven that was just seconds away from being destroyed. The seas were calm and shimmering, and groups of Triceratops grazed in the tropical sun. They had no idea that above them, a city-sized rock was slamming into Earth faster than any sound they could hear. After that, there wasn't just an extinction, the whole world was restarted. A whole age was wiped out in one day by fire, darkness, acid rain, and ice. This is the day-by-day account of how the world of the dinosaurs finished and how ours started. Dawn over a dying world. The Earth was alive in a way it has never been alive since 66 million years ago. The air was thicker, warmer, and wetter than it is now. It was like living in a greenhouse, and plants, palms and magnolias grew all the way up to Alaska. In what is now western North America, dawn broke through misty woods, full of the sounds of bugs, croaking frogs, and Triceratops bellowing far away. The sky was a hazy gold colour, and it was the kind of muggy morning where the air smelled like resin and wet dirt. From the fields to the sky, dinosaurs ruled every area. Each of them had no idea that the time they had left was running out. The Hell Creek region of modern Montana and the Dakotas was one of the last refuges of these Cretaceous giants. Vast river deltas wound across the land, fed by warm inland seas teeming with ammonites, sharks and mosasaurs. Titanosaurs lumbered through stands of ancient conifers. Hadrosaurs moved in herds across mudflats, leaving behind footprints that would harden into stone. At the edges of these herds, smaller predators like Dakota raptor waited for the weak to wander too far. High above, pterosaurs glided silently, their wings casting fleeting shadows over the ferns below. It was, for a moment, a perfect ecosystem, stable, thriving and unaware. But the world was changing, even though it was quiet. Geologists now know that the Deccan Traps, huge volcanic events in what is now India, have been going on for hundreds of thousands of years, filling the sky with sulfur and carbon dioxide. Already, global temperatures were changing more quickly than before, putting stress on food chains that had been in place for millions of years. Oceans started to become more acidic, and plankton groups, which are at the base of the food chain, were slowly dying out. This can be seen in isotopic evidence found in marine sediments. Any live thing that morning, though, would have thought nothing was wrong. On that particular day, the last of the Cretaceous, the sun rose over a horizon thick with haze and moisture. In the coastal forest near the Gulf of Mexico, giant flowering trees buzzed with insects, and birds descended from small raptor dinosaurs flitted between branches. Mosasaurs patrolled shallow tropical seas filled with ammonites and fish that glittered beneath the surface. Herds of horned dinosaurs trudged through ferns to feed, their massive horns scraping bark and tearing down young cycads. The world had no reason to suspect it was about to be erased. Far above the planet, however, a visitor was coming. Astronomers today can trace its path backward, a 6-mile-wide asteroid that had been orbiting the Sun for tens of millions of years, part of a much larger family of objects from the outer belt between Mars and Jupiter. Its composition, rich in iridium and nickel, suggests it came from a shattered parent body, a fragment of something far older than the Earth itself. For eons, it had drifted silently through the void. Then a nudge from Jupiter's immense gravity shifted its path just enough to intersect a blue and green planet below. In space, there is no sound. But if you could somehow hear motion, the asteroid would have screamed through the solar wind at 45,000 miles per hour. As it approached Earth, it began reflecting sunlight with such intensity that in its final hour, it would have been visible from the ground, a bright, steady star growing in the eastern sky. But for now, it was still high above the void, unseen, unnoticed, and seconds away from rewriting life's story. Below, the world went on with a beat. Along behind its mother, a young Triceratops calf chewed on soft cycads. A Tyrannosaurus slept nearby. It had just finished a good hunt the night before and was very full. Birds sang above a wet swamp, but their ancestors didn't know they were the lucky ones. The air was hot and pollen-filled, and dragonflies were dancing over small bodies of water. The earth slowly turned into what would look like a normal day for a few more minutes. The source. The predator's morning hunt. When a shadow started to move between the tree branches, the mist was still thick in the air. Tyrannosaurus rex, which was 30 feet long and 7 tons of muscle and bone, walked slowly and carefully. Ferns covered its every step, making it hard to hear. Its golden eyes were fixed on a group of Edmontosaurus feeding near the edge of the forest. As it breathed out, steam rose from its nose. The sound was low and repetitive, like thunder far away. It had spent its whole life hunting on these fields, and there was no sign of worry in its body. It was just another morning. The wind was calm and the ground was stable, though somewhere past the blue curve of the sky, the world was no longer stable. Paleontologists studying the Hell Creek ecosystem know this predator's morning well. Fossil evidence shows Tyrannosaurus often hunted at dawn or dusk, when temperatures were cooler and light filtered soft through the canopy. Its sense of smell was unmatched. The olfactory bulbs in its skull were larger than those of any other known dinosaur, allowing it to follow scent trails days old. Tracks preserved in the mud of ancient riverbeds reveal a purposeful stride, slow at first, then switching to a burst of speed in the final moments of pursuit. It was a patient hunter, built to deliver sudden, brutal efficiency. The calm of this morning's hunt is almost like being in a movie. While they eat cycads and horsetails, the hadrosaurs make a lot of noise, and their crests shine with dew. The young ones stay close to the middle of the group and flick their tails at bugs that won't go away. A few Pachycephalosaurus stay on the edges, heads down, looking for young shoots. Small animals run through the bushes. These are tiny nighttime survivors who have no idea that their kind will soon rule the world. Every step the T-Rex takes is a deliberate act of silence. Pterosaur wings cut through the lightning fog up above. With its wings folded, a Quetzalcoatlus searches the water for fish and dead animals. It doesn't need to look up. The asteroid is still a few minutes away from its closest approach, and the atmosphere is still quiet. Still, a small thing is changing. As the asteroid approaches Earth, boom, it sends out shock waves of air that can't be seen high up in the sky. The top atmosphere is affected by very small changes in pressure. No living thing could ever feel these changes, but they set the stage for the worst disaster in history. As the predator moves closer, the ground shifts slightly beneath its feet, not from the asteroid, but from something more immediate. The herd has caught its scent. One adult Edmontosaurus raises its head, eyes wide, nostrils flaring. For a split second, time seems to hold its breath. Then chaos. Dozens of hadrosaurs bolt toward the riverbank, trampling mud and ferns. The T-Rex lunges, jaws wide, its roar echoing across the delta. Teeth, as thick as a man's wrist, sink into flesh. A single Edmontosaurus falls, bellowing. The rest of the herd splashing into the shallows to escape. The hunt ends quickly. The predator stands over its kill, breathing hard, its face streaked with blood and steam. It's a perfect moment in a world that thinks it will last forever. Predator and prey locked in the endless cycle that has ruled Earth for over 150 million years. Overhead, the clouds glow faintly orange, but no one notices. A point of light has appeared in the Gulf of Mexico, still beyond the horizon. It is a piece of the universe starting its final fall. The 6-mile-wide asteroid is on fire as it starts to tear through the high atmosphere. In space, the impact is happening in seconds. On Earth, it's just another morning with the usual sounds of insects buzzing and waves hissing on the faraway shore. When the T-Rex bites, it has more than 8 tons of force, which breaks bones. A small animal nearby quickly jumps out of its hole, grabs a beetle, and then hides again. Life goes on the same way it has for a long time. The rock that erased an era. There is nothing but empty space above Earth, and a mountain made of stone and metal is dropping. More than 45,000 miles per hour, the asteroid that will end the age of dinosaurs is cutting through the sky. It is about 6 miles across and is made up of pieces of a broken world from the asteroid belt. It is full of iridium, nickel and sulfur chemicals. It moves slowly between Mars and Jupiter for tens of millions of years, being a peaceful drifter. Earth's gravity has now caught it and turned it into a city-sized bullet that is headed straight at the Yucatan Peninsula in Mexico. At first, the planet doesn't notice. Space is silent, and the void hides motion perfectly. But within seconds of entering the upper atmosphere, friction roars to life. The rock begins to glow, brighter than any object the Earth has ever seen. The air ahead compresses into plasma hotter than the surface of the sun. For anyone standing in what would become the Gulf of Mexico, the dawn suddenly blooms into an artificial sunrise. Shadows vanish. The jungle turns to mirror glass in the white glare. The asteroid's fall is so furious that it's hard to imagine. It moves so much air around as it goes through the atmosphere that shockwaves can't keep up with them and move faster than sound. The air falls back behind it, making a loud noise that shakes the whole world. Scientists who have studied this impact think that the rock has as much kinetic energy as 10 billion Hiroshima bombs in its last 10 seconds. It doesn't just hit Earth, it goes off right next to it. Moments before impact, the object pierces the troposphere over the Proto-Caribbean Sea. Beneath it lies a shallow shelf of limestone and evaporite rock rich in sulfur compounds. The worst possible target. When the asteroid hits, it compresses the seabed instantly, blasting vaporized stone and molten droplets thousands of miles into space. The core of the impact zone flashes to temperatures approaching 10,000 degrees Celsius. Water, air, and rock fuse into a single incandescent fireball. The impact crater will one day be called Chicxulub, after a small town that sits unknowingly atop its buried rim. But in this instant, there are no towns, no continents as we know them, no life within sight that survives. The asteroid punches 20 miles deep into the crust, vaporizing itself and much of the ocean above. A cavity nearly 100 miles wide opens in less than a heartbeat, ringed by walls of molten rock that collapse inward like liquid. Mega earthquakes ripple outward at thousands of miles per hour, cracking continental plates. In North America, trees snap like matchsticks as shockwaves ripple through the mantle itself. It sends pieces of crust, drops of liquid glass, and superheated dust into space, high enough to leave Earth's atmosphere completely. It rains down hours later after going around the world. One never come back. The whole Western Hemisphere is on fire in minutes. Animals that are less than 1,000 miles away don't even feel pain. The sound of the first blast wave moves faster than it does, leveling woods and boiling lakes. There is no more life on the ground after the Tyrannosaurs and Triceratops were destroyed. Seismic waves cause rivers to overflow even in what is now Montana, which is very far away. The impact's physics work on sizes that are too big for humans to understand. The rock is no longer there because it was turned into energy and plasma. But its effects are still felt today. Along with fine silicates and drops of liquid sulfur, a stream of vaporized rock shoots into space. There is electricity in the air. Anything that can catch fire is set on fire by lightning hits that last for hours. Along the beaches, winds that are strong enough to tear skin off of bones blow. On the other side of the world, in what is now Asia, animals wake up when the sudden brightness flares before dawn. This is called a ghost sunrise, and it happens because light is bent through melted rock high in the air. The Earth has moved into a new era of science and fire in less than 2 minutes. Impact, 0 hour. It seems like time breaks when the asteroid hits. Though it only lasts a second, this event changes the course of Earth's past for the next 66 million years. When the rock hits the ocean, it does so more than 20 times faster than a gun bullet. It cuts through 3 miles of water like air. That's when the pressure rises so quickly that the water doesn't splash. It turns into air in an instant. The ground below it melts, releasing energy equal to more than 10 billion Hiroshima bombs. At ground zero, there is no survival, not even at the molecular level. The air around the impact zone reaches temperatures of 10,000 degrees Celsius, hotter than the surface of the sun. Rock, salt, and sulfur boil and fuse into a glowing, expanding bubble of plasma that swallows hundreds of cubic miles of the planet's crust. That fireball expands upward faster than sound, punching a hole through the stratosphere and sending shockwaves through every layer of air. The ocean that once covered the Yucatan Shelf is hurled into space in a column of vapor, carrying billions of tons of water and molten debris that will rain back as glass and fire. At more than 1,000 miles per hour, the first impact blows everything in a circle the size of Texas Flat. Forests, rivers, and beaches are gone in a matter of seconds. Insects are burned up when they fly. Trees burn down before they can fall. Animals within hundreds of miles are not killed. Instead, they are erased and turned into ash. While feeding near the coast, a Triceratops never sees the sky light up. The light makes its body, bones, and even shadow disappear. The impact sends energy deep into the crust, generating earthquakes that register across continents. In North America, the ground ripples like liquid. Giant cracks rip open the land, releasing jets of boiling gas and molten rock. The shock travels through the mantle, causing volcanic fields thousands of miles away to erupt. Scientists who've studied the shocked quartz and microtectites from this layer say the impact's seismic waves carried more energy than every earthquake in Earth's recorded history combined. The air above you turns into a weapon. More than 25 trillion tons of matter are thrown into the high atmosphere by the explosion. Tekkites are pieces of molten rock that fall from the sky with fire trailing behind them. Larger pieces are thrown out of the atmosphere and go around the world. Within minutes, they start falling on the far side. As each stone hits the ground, it squeezes the air below it, changing it into a tiny meteor that lights up the sky wherever it falls. Then comes the blast wind. It races outward behind the shock front, a hurricane of superheated air moving faster than a jet. It strips soil from the ground and flings debris for hundreds of miles. Waves of pressure crush lungs, rupture eardrums, and flatten anything still standing. The sound that follows isn't a single explosion. It's a continuous roar that lasts for hours, a global thunderclap echoing through the atmosphere. The damage is felt far beyond the local area. Animals are thrown to the ground when ocean waves and winds meet in what is now the western United States. Rivers have a surface that rolls backwards. The mountains shake. In just a few minutes, air temperatures can rise by hundreds of degrees, setting brush and resin-rich woods on fire thousands of miles away. Underwater, the pulse of energy triggers chaos. The sudden displacement of the Gulf waters launches tsunamis that will later reach every ocean basin. Waves hundreds of feet tall fan outward at speeds faster than commercial jets, racing towards shorelines that will vanish within hours. Earth now looks like a world on fire from space. The scar from the collision is white hot and has a red halo of smoke and storm clouds around it. Through the ash and steam, lightning keeps flashing. A column of hot rock rises above the atmosphere and stretches into space before being pushed back by gravity. As the planet's magnetic field fights with the charged particles, the sky above glows a faint green and orange. The direct results of the hit are over in the first 10 minutes. The hole it made is gone, but the shockwaves are still going strong. But what began will last for a long time. Now there is a lot of sulfur, carbon and stone fumes in the air. As tsunamis grow, the seas start to rise. It will rain acidic rain from the sky. The sunshine that keeps the woods warm will be hidden by dust and soot. The fireball over North America. The asteroid lights up the whole area as soon as it hits. From what is now Montana to the Arctic, the sky gets so bright that no living thing could have stood it with their eyes open. A few seconds after contact, the rock and water evaporate and shoot up at hypersonic speed, through the atmosphere and into space. But gravity pulls it back, sending billions of tons of molten rock and metal hurtling across the Earth and then falling again. Each sparkling drip goes back into the sky at a temperature of 1,000,000 degrees, which makes the night into a furnace. Over North America, the first fallout begins 20 minutes after impact. From above, the sky resembles a galaxy in motion, streaks of incandescent glass tracing fiery paths across the clouds. On the ground, it feels like the air itself is burning. The returning debris ignites oxygen as it falls, raising the lower atmosphere to hundreds of degrees. Across forests, plains and deltas, the temperature spike turns leaves to ash, bark to charcoal, and soil to smouldering crust. Dinosaurs far from the crater, thousands of miles away, don't even see flames. They simply collapse, their lungs scorched by superheated air. This is not fire in the way humans understand it. The entire sky radiates heat like an open oven. Scientists studying soot and clay from the Cretaceous-Paleogene boundary call it the thermal pulse. It lasted less than an hour, but it cooked the top layers of the planet. The surface temperature in many regions exceeded 400 degrees Celsius, hot enough to boil water, melt resin, and ignite entire forests at once. Fossil charcoal layers found in North Dakota and Alberta confirm that even wetlands burned. Only animals underground or underwater had any hope of surviving the first fallout. As debris continues to rain down, the horizon glows blood red. Lightning storms ignite in the dense dust-laden air, flashing over black smoke and burning wood. The combined roar of storms and global wildfires drowns out everything else. The sound doesn't stop. It's the constant hiss of oxygen feeding flames. Across what was once lush woodland, trees fall and burn, sending pillars of smoke into the stratosphere. Each ton of soot that enters the sky will soon block sunlight and poison the rain. In the chaos, few large animals escape. A herd of hadrosaurs tries to cross a drying river, the water already steaming. A Quetzalcoatlus glides blindly through the haze, its vast wings catching heat currents it can't control. Far to the north, a Tyrannosaurus seeks refuge in a low gully, its massive body trembling with exhaustion. Even hundreds of miles from the crater, the light is too intense. The T-Rex turns its head toward the sky, an ancient instinct to track lightning, and sees nothing but red fire. For marine life, the ocean's surface becomes a mirror of the sky's torment. As fiery rock fragments strike the water, steam explosions blanket the coasts. Temperatures near the surface soar, killing fish and plankton instantly. In shallow bays, the heat bakes coral reefs and drives marine reptiles into deeper, colder layers, only to trap them as oxygen levels drop. Some modern scientists believe this global broil phase lasted less than 2 hours, but was enough to burn most vegetation on the continents and sterilize surface waters worldwide. A cloud of rock that has been heated up starts to spread around the equator above it all. It will go around the world in a day, bringing fine ash and sulfates that will make the Earth darker for months. But North America is still shining right now. Soot rises into the upper atmosphere, where it soaks up sunshine and sends it back down, fueling the fires below in a dangerous cycle. As the sky burns, the first stage of mass extinction is already locked in. Photosynthesis halts. Oxygen levels dip as forests vanish. The animals that survive this hour will face a world without food, warmth or light. Yet in burrows beneath the scorched ground, small mammals press against the soil, their hearts racing. Frogs bury themselves deeper into mud, and turtles sink into the bottoms of ponds, finding the only refuge left: darkness, silence, and cold water. The ocean turns to steam. The asteroid didn't hit land, it hit the edge of a small sea. That one fact sealed the fate of the seas on Earth. The impact site, which is now the Gulf of Mexico, was covered by warm, carbonate-rich water that was only a few hundred feet deep. Layers of sulfur and limestone that turned to gas right away were under that water. In less than a second, billions of tons of seawater exploded into the air as superheated gas. This made the ocean around the volcano grow into a dome of steam. At the impact centre, the water didn't just boil, it vanished. The crater's walls rose, collapsed, and rose again in a series of rebounding waves, taller than mountains. Every molecule of water that touched the impact zone was converted to gas, mixing with molten rock to form a colossal glowing plume. That plume blasted into the stratosphere, dragging with it shattered coral and marine life, now reduced to microscopic ash. The result was a global pulse of vapour that transformed the nearest ocean basins into instant pressure cookers. In the first minutes after impact, tsunamis hundreds of feet tall radiated outward across the Proto-Caribbean. Shockwaves raced through the seabed at the speed of sound, shaking continental shelves loose. The first wave front struck the coasts of what's now North America within minutes, tearing forests and soil into the sea. The second wave, reflecting off the opposite coasts, returned with equal fury hours later. Computer models suggest these tsunamis reached as far as the Atlantic coast of Africa within a single day, their crests still dozens of meters high. In the shallow seas, life met its end in silence. Mosasaurs, the top marine predators of the age, had no time to react. The water around them reached boiling temperatures within seconds. Fish and ammonites burst as the heat expanded the gases in their bodies. Plankton, the very foundation of the food chain, cooked in layers so dense that it later left a thin line of organic rich clay across the sea floor. The boundary geologists would one day call the KPG line. Almost everything that was alive in the high seas died right away. But that wasn't the end of the damage. Huge amounts of water vapour were pushed into the atmosphere by the heat and pressure, making clouds that gave off a faint glow at night. The sulphur and carbon dioxide from the rocks that were being burned off mixed with that mist to start a world acid storm. The chemistry of the ocean started to break down when acidic rain fell back into it. This broke down shells, coral and the fragile structures of marine plankton. Geologists studying deep-sea cores from around the world find a sudden break in the record here. One layer is full of foraminifera, tiny shelled organisms. The next is nearly empty. In a matter of weeks, the ocean went from vibrant blue to lifeless grey. Temperatures near the surface spiked, while the depths grew colder as circulation stalled. Without sunlight or photosynthesis, oxygen vanished from the deeper layers. The ocean began to suffocate. The waves from the Gulf came back in a bizarre shape. As tsunamis came back up from the shore, they carried sand, trees, and the remains of whole ecosystems with them. When they rushed back out to sea, they took the bodies of dinosaurs, lizards, and forest animals. These bodies formed floating mats of decay that moved for weeks before they sank. The smell of the ocean turned into the smell of the world's end. Meanwhile, on the opposite side of the world, the Pacific was still reacting. Pressure waves from the impact had crossed the entire planet, dislodging sediments, collapsing volcanic slopes, and triggering new undersea eruptions. The oceans groaned as tectonic plates flexed. Even in regions far from the crater, Marine life faced scalding rain and sudden darkness as soot and ash began to blanket the surface. The sky that burned. The Earth's atmosphere turns into a weapon minutes after the impact. Molten rock, melted water, and pieces of crust rise above the atmosphere and start their long fall back to Earth. As they come back together, contact sets the air on fire. The sky over the whole world becomes a global oven, with a dome of glowing plasma that goes from horizon to horizon. To anyone who might have looked up from the dark side of the planet, it would have seemed as though dawn had arrived all at once. The night sky glowed orange and white, brighter than the sun, as falling debris blazed through the upper atmosphere. Each fragment was small, grains of glass, droplets of molten rock, but there were trillions of them. They compressed the air beneath them as they fell, creating enough heat to ignite the surface of the world. Across continents, forests, plains, and even deserts burst into flame at the same time. This global broil phase, as scientists call it, lasted less than an hour, but it marked one of the most lethal moments in Earth's history. Temperatures at ground level spiked high enough to melt tar, vaporize resin, and char the leaves of every living tree. Fossil charcoal layers from Montana, Saskatchewan, and Alberta prove that these wildfires spread across the entire northern hemisphere. Even wetlands and river deltas, normally fireproof environments, were scorched. Only animals that could burrow, dive, or hide deep in water stood any chance at all. In the skies, the fallout was as violent as any storm. Air currents reversed, driven by intense heat radiating off the planet's surface. Winds of hundreds of miles per hour carried ash and burning embers across oceans. The first firestorms joined together into continent-wide infernos. Oxygen levels plummeted as the flames consumed every forest. The sound of the world burning was constant, thunder without rain, wind without pause. High above, the chemistry of the atmosphere changed forever. The superheated debris cloud mixed with nitrogen and oxygen to create nitric oxides, poisons that would later form acid rain. Dust and soot began to accumulate in the stratosphere, absorbing sunlight and re-radiating it as heat. The glow in the sky intensified, turning entire horizons red. The effect was both beautiful and fatal, an aurora of death stretching around the planet. Life suffered under this bright doom, even in places thousands of miles away from the crater. Ferns died, even though they were far away in Antarctica, and animals hiding in forest caves in what is now Europe felt the air above them get so hot that it burned. Little eagles from the Cretaceous era gave rise to birds that flew into smoky skies, the flames reflecting off their wings and lighting them up. Some made it to lakes or islands, but most of them fell before the end of the first day. The rain that followed was not water. Superheated vapor condensed into drops of molten glass, microtectites, that streaked across the heavens and pelted the surface like burning hail. Lakes hissed and boiled, rivers filled with ash and dead fish. The surface of the earth, once lush with green, now reflects orange, then black. The atmosphere carried the scent of sulfur and carbon, the breath of vaporized rock. Modern scientists, analyzing layers of clay from this time, can still trace the mark of this burning sky. In that thin band lies iridium, an element rare on Earth but common in asteroids. It's the signature of impact, the cosmic fingerprint of the intruder that ignited the world. Mixed within are glassy spherules, droplets of rock melted and refrozen in mid-air. Each one is a bead of evidence, a tiny witness to the day the sky itself turned against life. Still, this global inferno had its limits. Soon the sky was full of smoke and soot, which blocked the sunshine that was supposed to feed it. Within days, the fire began to lose its food supply. Fires went out, not because they were put out, but because it was too hot to breathe. The glow went away, and a deep red gloom took its place. the hour of total darkness. It doesn't feel right when the last fires go out. The sky, which was white hot just a few hours ago, is now the colour of ash. The impact sends dust, soot and aerosols into the atmosphere, where they stay. They make a blanket so thick that sunlight can't reach the ground. Earth goes from being a fiery fire to a dim, never-ending twilight in just one day. It looks like dusk at noon. Behind a grey roof of broken stone, the stars are gone. Scientists estimate that within 48 hours of the impact, the entire planet was cloaked in a dense cloud of silicate dust and sulfur gas. These particles scattered and absorbed sunlight, reducing global brightness by more than 90%. On land, the effect was instant winter. Photosynthesis halted almost everywhere. Plants that survived the firestorm now faced starvation. Trees, stripped of leaves, stood as black skeletons against a darkened sky. Ferns wilted, and entire forests turned from green to grey within days. The temperature began to plummet. Dust particles high in the atmosphere reflected sunlight back into space, and with each passing day, less heat reached the ground. In what's now North America, the air dropped from tropical warmth to near freezing. Rain no longer fell. It condensed into drizzles of ash-laden mud. The smell of smoke and sulphur hung everywhere. Even in the tropics, frost formed before dawn. This was the beginning of what geologists call the impact winter, a planetary night that would last for months. For animals that survived the fires, this new darkness brought confusion and hunger. Herbivores that had escaped the initial blast now faced a world without food. The leaves they depended on were gone, and new ones could not grow without sunlight. Insects vanished, depriving small reptiles and birds of their main prey. Even the massive river systems, once rich with fish, fell silent as algae and plankton died in the dark. The predators didn't do any better. Tyrannosaurs that were still hurt from burns or broken bones wandered around aimlessly, since their area and food were gone. Some people scavenged on the shores for bodies and other things that the tsunamis had left behind, but the smell of millions of tons of dead bodies made the air sick. Carrion bugs and small animals dug into dead bodies wherever they could find them. They did very well for a short time on the rotting matter before it ran out. The big hunters from the Cretaceous, which were made to be powerful, were now going hungry because the sky wouldn't get brighter. Modern research using carbon isotopes shows how fast the biosphere collapsed. Within just a few weeks, atmospheric carbon dioxide dropped as plants stopped photosynthesizing. Without sunlight, global oxygen levels declined. The planet's energy flow, the link between sun, plant and animal, snapped completely. The Earth was alive, but in a coma. Some regions may have seen faint flickers of light, auroras triggered by the charged dust in the atmosphere. To any survivor, it would have looked like ghost fire, shimmering at the edges of a dying world. Nights were endless, broken only by the dim red glow of smouldering horizons where volcanoes still rumbled. The Deccan traps in India, already active before the impact, belched even more gas into the dark, feeding the global chill. In lakes and ponds, turtles and crocodiles buried themselves deep in mud, slowing their heartbeats to a crawl. Mammals huddled underground, their small bodies conserving heat. Some birds, small enough to survive on stored fat or seeds, perched in the ruins of burnt forests. They didn't know it, but they were the future, the heirs to a broken Earth. It took months for things to start to settle down. The light that got through was still weak and red, more like dusk than morning. The weather around the world has changed a lot. There was no difference between day and night anymore. They were both dark, cold, and quiet. The frozen rain of death. The sky went from red to iron grey as the nights got longer and cooler. The fires were no longer very hot, and the planet was now at its most dangerous. As the water on the ocean floor evaporated, sulfur and chlorine gases from the surface mixed with the air above to make acid particles. When these drops got heavy enough, they started to fall. It sounded like rain when it hit the ground. What was supposed to be the first rains to clean up after the fire turned into a chemical attack. The first drops were not cold, but corrosive. They splattered against ash and soot, fizzing as they reacted with minerals. Lakes foamed. Rivers, already choked with burnt debris, turned milky white as calcium carbonate and silicates dissolved. pH levels in the surface waters plunged. Modern geochemical models show that within weeks, the upper layers of the ocean turned as acidic as battery fluid. Shells of plankton and mollusks made of calcium carbonate began to dissolve where they floated. In a geological instant, the ocean's great shell makers, the base of its food chain, disappeared. On land, the acid rain stripped entire ecosystems bare. Forests that had survived the fires found their leaves eaten away by invisible burns. Needles fell from conifers, leaving only dark, skeletal trunks. The soil beneath became toxic, nutrients leached out, and seeds that had escaped the flames now rotted before sprouting. Rivers carried this poison downstream, turning floodplains into chemical graves. The scent of burnt vegetation was replaced by something sharper, a sting of sulfur that made breathing painful. Fossil evidence confirms this chemical nightmare. Layers of clay from this time show massive spikes in sulfur isotopes, proof that acid fallout reached nearly every corner of the planet. Limestone formations, usually smooth, show etched pits from chemical erosion. Even the bones of some surviving reptiles and amphibians display early signs of acid damage, as though the very air had turned against life. It rained non-stop, but in spots that changed with the soot patterns in the air. Some places, like the tropics in the southern hemisphere, had rain that was so acidic that it killed all the fish that lived in fresh water. In other places, it dried out completely, keeping the cold in as winter got worse. In the middle areas, it got below freezing. Little lakes that had boiled days before got ice on them. The planet's weather was now rapidly changing from very hot to very cold. This was caused by dust, soot, and chemical haze. Animals that had survived by hiding underground now faced poisoned water and barren land. Amphibians, which needed clean pools to breed, vanished in droves. Insects, the decomposers that recycled dead matter, died off as their larvae were scorched by acid rain. With decomposition slowed, the world filled with decay that would not rot. Carcasses lay where they had fallen, coated in black sludge. The air stank of sulfur, methane, and death. The acid did more than just damage, it changed the shape of the Earth's surface. Minerals that were dissolved in rainwater were carried back into the sea, making thick beds of gypsum and anhydrite near the impact site. On an unthinkable size, these sediments tell the story of chemical weathering happening all over the world. Ancient soils and rocks were washed into the new seas in just a few years, which is the same amount of time that erosion takes over thousands of years. Above this devastated world, the sun was a dim orange disk, sometimes visible through thin breaks in the haze. When its rays struck the acid droplets still hanging in the air, they scattered into pale halos, ghostly rings in a dead sky. Each beam of light was filtered through a chemical veil that ensured life's struggle would continue in misery. It could be months or even years before the acid rain stopped. They finally stopped, but they left the world with rivers dead of life, lands bleached white, and seas hurt at their core. Earth's flesh had been burned by fire, but this rain had been burned by its blood. There was only poisoned quiet left as people waited for the next part of the end to begin. Survivors in the ash. After the sky turned black and the acid rain started, the world became so quiet that no living thing had ever felt it before. Dark tree stems that stood out like the ribs of a burned-out temple were blown around by the wind. The ground was soft and grey, and there was so much ash and soot on it that it covered whole continents. Even in the tropics, the air was so cold and thin that it turned into mist when you breathed in. There was still life below that empty wreck, though. In the absence of sunlight, warmth and green, survival became an act of invisibility. The animals that had once ruled the surface, dinosaurs, pterosaurs and giant reptiles, were gone. But the smallest forms of life endured by vanishing from sight. Mammals, long confined to the shadows of giants, retreated deep underground. Fossil burrows in the ancient floodplains of Montana and Patagonia show the traces of small creatures, shrew-like multituberculates and early placentals that survived the first year by hibernating beneath layers of ash. Their bones reveal thickened growth lines, proof of long fasting periods broken by rare feedings. These were the first survivors of the new Earth. Reptiles changed in different ways. Crocodiles, which can already live in water to some degree, waited out the disaster in the mud and water. Because they had cold blood, it was easy for them to go without food. In the rivers that didn't have much air or nutrients, they slowed down, sank into the mud, and let the anger of the world pass over them. Turtles did the same thing. They hid under wet silt and only came out when the air got a little warmer. Their quiet strength gave them a place even in this dying world. Birds, those that survived, were few and fragile. Fossil sites show that nearly all large bird lineages vanished, but small ground-dwelling species with seed-based diets pulled through. Seeds, scattered across the ash, became the most reliable food source left. The ancestors of modern ducks, chickens and songbirds carried that luck forward. In a sense, the future song of the forests was already present, sleeping in the ashes. Even though it was quiet, the ground wasn't dead. Microbes started to break down the dead because they were protected by the deep and the moisture. Fungi grew on dead animals and downed logs, turning death into food. Fungal seeds from this time period show a huge increase in the number of fungi. This is called a fungal spike, and it marks the start of the world's slow restart. The tiny decomposers did very well as each giant broke down. The new kingdom of life was very small and ate the dead things that the old kingdom left behind. Each region of the planet became a patchwork of nightmares for survival. In lakes and ponds, algae began returning first, feeding on the minerals washed in by the acid rains. In shallow burrows, mammals bred quietly, their offspring feeding on insects that had also survived underground. The ecosystems that re-emerged were not diverse, but they were determined. Geologists have found that the first vegetation to reclaim the land was not trees, but ferns. Their spores could lie dormant through darkness, waiting for light. When sunlight began filtering weakly through the haze, fern spores germinated everywhere at once. This global fern spike appears in the fossil record like a signature of resurrection, a green whisper in the silence of grey. The planet was still dangerous. The temperatures kept going up and down wildly, and there wasn't much food. In the years that followed, many of the early survivors went hungry. When the first animals crawled out of their dens, they saw a world that was empty. Their little hearts beat quickly under skies that rarely cleared. Still, they made it through by changing, collecting and waiting, just like their ancestors had always done. It would have been scary to stand on Earth back then and see a grey wasteland with thin stripes of green, the smell of smoke from the burned-out woods still in the air, and the first timid steps of animals discovering the light after a year of darkness. Even though the dinosaurs were gone, evolution was still going strong. Life had gone on quietly under the ash, waiting for the time to start over. The global tsunami return. There was quiet and ash on the land, but the seas were still moving. The energy that the asteroid released was still being felt in the oceans hours after it hit. The first impact sent walls of water everywhere. Now those waves were coming back, bouncing off of continental shelves, meeting in the middle of the ocean, and coming back to the beaches as loud, black tsunamis. They brought with them woods, bodies, and broken islands that the first waves had destroyed. Every new surge wasn't a wave of water, but a moving cemetery. In the Gulf of Mexico, the first rebound arrived roughly 12 hours after impact. The crater was still molten, its rim glowing orange through clouds of steam, when a wave taller than city buildings curved back toward it. Travelling at nearly 500 miles per hour, it gathered speed across the shallows, carrying the wreckage of a continent. Logs, bones, and Dead Sea reptiles churned together in a slurry of oil, silt, and ash. When it struck the crater basin, it exploded upward, sending fountains of boiling seawater and debris into the sky. The impact site that had ended the dinosaurs was now being scoured clean by the ocean, trying to reclaim itself. Across the western interior seaway, the vast inland ocean that once split North America in two, tsunamis thundered northward. In what's now South Dakota, fossilized layers of mixed marine and land sediments show how the waves carried sharks, ammonites, and land plants into one chaotic deposit. Fish were buried alongside tree trunks and dinosaur bones. These layers, found today in the Hell Creek Formation, are the sedimentary fingerprints of the moment two worlds, land and sea, merged in catastrophe. Farther away, the echoes of those tsunamis reached every coastline on Earth. In South America, waves tore through mangrove swamps and estuaries, dumping saltwater miles inland. Along the shores of Africa and Europe, they arrived smaller but relentless, stirring up sediments that had not moved in centuries. Even the Pacific, half a world away, was not spared. Wave models suggest that the largest troughs took nearly 24 hours to circle the globe, their energy sustained by the sheer scale of the ocean basin. Where the waves met the returning currents, they made huge vortexes that gathered anything that floated, like dead sea turtles, trees that had been removed, and the bodies of dinosaurs that had been swept out to sea by floods. Before they sank, these rafts floated for weeks or even months. They turned into tiny communities of rot, where swarms of bugs and fish ate the dead things. But when the temperature and oxygen level dropped, even those scavengers died, adding to the rising mats of death that floated across the dark ocean. For marine life that had survived the heat and acid rain, the returning tsunamis delivered the final blow. Shallow reefs were torn apart. Coral skeletons crumbled under the weight of sediment. Entire schools of fish were swept into the open ocean and left to starve in black, oxygen-deprived water. In the deep sea, where shock waves had triggered underwater landslides, vast clouds of silt smothered the sea floor. Layers of fine clay from this time now form a distinct band in marine cores, evidence of a global burial that silenced the seas. The world was still dark above the water. Behind dirt clouds, the sun was a fuzzy smudge that didn't give off any heat. In that late afternoon light, the waves kept rolling, heavy and slowly. They changed the shapes of coasts so that they were no longer recognized. Deltas were smoothed out and mangroves were gone. Even the smell of the sea had changed. There was no longer any salt or life in the air. The seas let out their last roar as the tsunamis finally stopped. The surface fell to an eerie silence that was only broken by pieces of garbage floating by. As the bodies swelled, broke and sank, pieces of the old world fell to the ocean floor. Bacteria and chemical reactions kept the slow process of decay going, changing bone and skin into food for any tiny living things that could survive the cold. The planet without sunlight. After weeks, Earth is no longer on fire, but it is also no longer shining. The sky is still full of soot, sulfur, and broken stone, which turns the sun into a dim red glow that never really turns daytime. The Earth looks like a bruise from space, with dark grey oceans and a whirling cloud of ash. It looks and feels like dusk has frozen over. Around the world, temperatures drop by more than 20 degrees Celsius. It's cold now, where it used to be a warm garden world. The fires that consumed forests across the continents have filled the atmosphere with nearly 100 trillion tonnes of carbon dioxide, ash and sulfuric acid aerosols. The sulphur reflects sunlight, scattering it away from the surface, while the carbon traps infrared heat that can't escape. The result is a deadly paradox, a greenhouse wrapped inside a refrigerator. The upper atmosphere burns with energy, but the ground freezes solid. In what's now North America, layers of soot blanket the ground like black snow. Lakes and rivers have stopped flowing, their surfaces sealed by ice even in the tropics. Rain has turned to sleet mixed with ash. The silence of this new winter is total. No birds call, no insects hum. The only sound is the wind hissing through forests of dead trees. It carries a faint chemical tang, the smell of sulphur and decay, reminding everything still alive that the air itself has changed. Scientists today call this phase the impact winter. Geochemical models and fossil evidence show that for at least 6 months, sunlight reaching Earth's surface dropped to less than 1% of its normal level. Photosynthesis collapsed entirely. Plants that survived the fires now die from starvation. Marine algae and plankton, responsible for producing most of the planet's oxygen, vanish from the upper layers of the sea. With no new oxygen and no food, the global biosphere begins to suffocate. In the oceans, surface temperatures fall sharply. Cold, dense water sinks, disrupting global circulation. The deep sea becomes a stagnant trap, deprived of oxygen. Massive die-offs of plankton, ammonites and small fish follow. Marine reptiles that survive the heat waves starve as prey disappears. The oceans, once the engine of life, become vast deserts of cold water. On land, the darkness turns every creature into a scavenger. Crocodiles linger in half-frozen rivers, snapping at anything that moves. Mammals dig deeper into burrows, feeding on roots and whatever they can gnaw from frozen carcasses. Birds with seed-based diets cling to life, their small bodies conserving heat under layers of ash. For most species, however, the chain of survival has already broken. Without sunlight, there is no plant life. Without plants, there is no herbivore. Without herbivores, there is no predator. The environment turns into a killer. Since the sun isn't shining, photosynthesis can't get rid of carbon dioxide. Instead, volcanoes and dead plants and animals keep adding it. Even though there is a lot of sulphur in the air, the surface still feels cold. There is less air and more acid in each breath. The cold gets into both the ground and the bones. Temperatures in the middle latitudes dropped to almost freezing in the summer and stayed that way for decades, according to fossils. Across the world, geological layers record this silence. Sediments from this time show no pollen, no algae, no coral growth. It is a global pause in photosynthetic life. Earth systems stalled. The only colours left are grey, white and black. Even the oceans lose their blue, reflecting the metallic haze above. Still, there are small places where life goes on under the ice and ash. Deep in the ocean, at hydrothermal vents, bacteria are still feeding on chemical energy without knowing what's going on above. Heat patches in volcanic areas keep small ecosystems alive. These ecosystems are made up of ferns, mosses and hardy mushrooms that stick to warmth. Small animals and mice stay alive underground by hibernating and picking through seeds. Frogs and turtles lie still in ponds that are frozen over. Their bodies have slowed down so much that they are almost still. The last roars fade. The weeks following the start of impact winter are the loneliest in Earth's history. Once filled with the sound of footsteps and roars, the woods are now empty fields of ash and ice. There is no sound in the air, not even the buzzing of bugs, because it is thin and cold. The big dinosaurs that are still alive after the fires and tsunamis walk around their destroyed world, getting hungry and lost as the skies never get brighter. A single Triceratops walks through grey snow in what is now western North America. The tips of its horns are chipped from the frost. This animal used to eat ferns, cycads and flowering bushes. Now those plants are gone, either burned to a crisp or frozen solid. The ground under its feet is dead, with no roots left. Every breath out turns into a mist in the cold air. The earth doesn't shake when it falls because the ground is too soft and full of ash. A young Tyrannosaurus sits nearby and watches, but it doesn't attack. You have nothing left to gain. Both are stuck in a time and place that can't feed them anymore. Across the hemisphere, the story repeats. In Asia, herds of hadrosaurs crumble into skeletal remains, their tracks leading nowhere. In Antarctica, small predatory dinosaurs freeze along the coasts that once teemed with lush vegetation. Even the oceans, where mosasaurs and plesiosaurs once reigned, are silent. With plankton gone, their prey vanish, and they starve in dark, cold water. For a while, the scavengers hold on. Raptors, smaller theropods, and carrion feeders follow the trails of the dying. They tear at what's left of carcasses blackened by soot, but the meat is toxic now, saturated with acid and ash. Fungal infections spread through wounds. Parasites multiply in the dead air. Fossil evidence shows bone lesions and signs of starvation in the last dinosaurs, suggesting slow, painful declines rather than sudden death. These are not creatures killed by one explosion. They are species unraveling from hunger, cold, and time. The ecosystem collapses layer by layer. First, the largest herbivores disappear. Then their predators, deprived of prey, follow. Finally, the smaller specialists, those that feed on insects, seeds, or aquatic plants, fade into extinction as their food chains crumble. The age of abundance that began 160 million years earlier dissolves into emptiness. The earth that once supported towering forests, endless swamps, and seas alive with monsters now holds only dust and bones. Even the sounds of life vanish. The deep bellows of sauropods, the calls of hadrosaurs, the rumbling growls of tyrannosaurs, all gone. For the first time since vertebrates conquered land, there is no large animal anywhere on Earth to shake the air with its voice. The only noises left are geological: wind over rock, waves over frozen coasts, and the crack of cooling crust near the crater in Mexico. Still, warmth still remains below the surface. Many small animals hide in holes and ponds to wait out the long night. Mammals feed their young saved seeds while they are warm and protected by their fur. When crocodiles sleep under ice, their hearts beat very slowly. When the sun comes back out, the frozen frogs and turtles will warm. They are the last lights of an ecosystem that won't go out. Paleontologists have traced the final presence of non-avian dinosaurs to within a few thousand years after impact, a blink in geological time. The fossil record shows their disappearance as abrupt, but not instantaneous. There was no single day when the last one fell, but rather a dim, drawn-out fade. Somewhere on an island or floodplain, a few survivors may have outlived the others for years, clinging to the memory of a vanished world. Eventually, hunger and cold found them too. The scavengers reign. A new kind of country comes into being when the giants stop talking. The time of hunters and prey is over. Now it's time for scavengers. The world is full of graves, and only those who can eat death will be able to stay alive. They are the first to come out of the mud. They move slowly, pulling their armoured bodies through swamps that are half frozen and full of dead bodies. They have lived through disasters for millions of years and are designed to be hungry and patient. Their digestion lets them go for months without eating, which is now their most powerful trait. As the swollen bodies of dinosaurs wash into the shallows, they eat them. They also eat fish that have died from acid rain and each other. Bones with bite marks from other animals show that these animals lived by eating each other and breaking down. Above ground, mammals begin to stir from their burrows. They are small, shrew-like things, furred, warm-blooded, with fast hearts and desperate instincts. For months they have lived in darkness, feeding on roots, seeds and insects that somehow endured the cold. Now, in the brief breaks of weak sunlight, they emerge cautiously. The air is still poisoned, the ground slick with rot, but their senses are sharp. They scavenge what they can: bits of meat, fungal growth, dead insects. In this silence, they become the planet's new opportunists. Insects too claim their empire. Carrion beetles, maggots and flies swarm over corpses that stretch for miles across the plains. Fungi and bacteria work in tandem, dissolving flesh into soil. Geologists studying post-impact sediments find a strange signature from this time: a fungal spike, a sudden global bloom of spores that filled the atmosphere. The world was rotting on a scale it never had before. The decomposition of millions of tons of animal matter pumped carbon and methane into the air, prolonging the haze that kept the planet cold. But it also began the slow process of renewal. The rivers and coasts are thick with debris. Turtles float among it, their shells darkened by soot. They feast on anything edible: soft tissues, decayed plants, fish carcasses. Their eggs, buried deep in ash, survive the cold and hatch months later, continuing the line. The survivors of this time are not beautiful or mighty. They are persistent, unbothered by filth, and impossible to kill. Everywhere, the scavengers' rule looks the same: rats, descendants of early mammalian insectivores, move through the ruins of forests, gnawing on bones. Amphibians creep out from mud cracks, their slick skin glistening with ash. Even birds, those fragile heirs of dinosaurs, scavenge when they can. With insects dying and seeds scarce, some pick at carcasses left along the water's edge. The delicate elegance of flight now serves survival, carrying them between scattered sources of food. But this dark ecosystem, which is based on death, becomes the way to life. As the scavengers eat, they move nutrients around, turning dead bodies into dirt and earth into plants. In places where decline is worst, green will come back first. Fungal mats turn nitrogen and phosphorus into the building blocks of new environments below layers of ash and bone. The process could last for years or even decades, but it starts here with the worms and bugs. Paleontologists have found bone beds from this period packed with mixed remains: fish, reptiles, mammals, all crushed together in chaotic layers. They're the remnants of tidal floods, scavenger pits, and rotting floodplains. Yet even in this chaos, there's evidence of renewal. Burrows cutting through older sediment, small footprints pressed into soft mud, fern spores embedded in the topmost layers. Life is reorganizing itself from the bottom up. For the scavengers, each day is the same grey struggle. The sun still hides behind the haze, the air still bites with cold. But they endure because they are adaptable, omnivores, detritivores, survivors. The dinosaurs' age had been ruled by dominance. This new one is ruled by resilience. The oceans go silent. Deep below the waves, the effects of collision play out in a very clear way. A lot of ash and dust have made the sea's surface less bright. They used to be full of colour and life. The sunshine that fed plankton can't get through more than a few feet now. The base of the seafood chain falls apart without that light. There is silence in the ocean for the first time in a very long time. In the first weeks, the surface waters cool rapidly. Ash and sulfur particles drifting down from the sky mix with rain and fall into the sea, making it acidic. The pH drops to levels that dissolve the calcium shells of foraminifera and ammonites. Microscopic life, the planet's most abundant source of oxygen, dies almost instantly. When plankton vanish, everything above them in the food web begins to starve. The change spreads with terrifying speed. Coral reefs bleach and crumble into dust. The vibrant Cretaceous coral gardens, once home to fish, crustaceans and giant clams, vanish in less than a year. Mollusks, unable to build shells in the acid water, fail to reproduce. Even the massive marine reptiles, mosasaurs and plesiosaurs, that survived the shock waves and tsunamis, now drift aimlessly through dead seas. Their bodies grow weak, their prey gone. Some beach themselves in confusion. Others sink slowly to the dark, cold bottom. Geological cores taken from ocean floors today show this catastrophe frozen in stone. At the boundary between the Cretaceous and Paleogene layers, there is a thin, dark band, rich in iridium, soot, and microscopic glass spheres. Below it lies a world full of fossils. Above it, a barren void. It's the geological fingerprint of silence, the moment the ocean stopped breathing. The oxygen that once circulated through warm currents becomes trapped as the water cools. Deep sea circulation halts, creating vast anoxic zones where nothing larger than bacteria can live. Hydrogen sulfide, a toxic gas produced by decaying plankton, begins to fill the depths. It seeps upward, poisoning what little life remains near the surface. The seas that once smelled of salt and algae now stink of sulfur and rot. At first, only scavengers stay. Clams and other crustaceans eat bones that fall to the ground like slow rain when people die. Worms and giant isopods crawl through the silt and eat what the land's destruction leaves behind. These things can only last for so long. When air levels drop, they also die. The fine dust of extinction covers the ocean floor and turns it into a graveyard of still bodies. Above the waves, the devastation mirrors that of the land. The wind pushes waves over coastlines stripped of life, washing away forests of kelp and seagrass. The tides are colder now, slower. Each one deposits another layer of ash and bone. Birds that once hunted over the water vanish, their food gone. Even the sound of the surf dulls, muffled by layers of drifting soot. Still, there is endurance in the deepest parts of this dead ocean. Instead of sun shine, bacteria grow around hydrothermal vents, which are deep below the continental plates. They eat carbon and iron and don't care about the damage going on above. There is still life in these hidden places, with worms and crabs living in small communities that will one day bring life back to the sea. This is where the next stage of growth starts, in these dark depths. The seas of the future will be home to animals that can live without light or air. Over millions of years, they will change into different types, giving rise to the relatives of fish and whales we know today. Still, that new life is a long way off. The seas are still for now, the top is empty, and the depths are full of ghosts. The Earth looks cold and empty from space. Its water is now steel grey instead of the deep blue it used to be. The world of life has turned into a world of echoes. There is still steam rising into the sky above the hole in the Yucatan. Weak currents move through the world's basins, pulling the last of the dinosaurs' world into the deep. The first green shoots. As the months turn into years, the Earth starts to move again. The rains and fires are over, and the thick layer of dust and ash is slowly drifting back to the ground. Weak, filtered sunlight finally breaks through the clouds. What it shows is a world that has been stripped down to its bare bones, with seas that are still grey from silt in the soil. Still, the first bit of colour comes back to this wasteland. Fossil layers from this time show something astonishing. Above the dark band of soot left by the asteroid's fires, there appears a fine layer filled with fern spores, billions of them. Paleontologists call it the fern spike. It marks the exact moment when life began to recover. Ferns, hardy and ancient, thrive in the aftermath of disaster. Their spores travel easily on the wind, and they need almost nothing to grow. They were the first to take back the land, sprouting across ash fields, crater rims, and the charred skeletons of forests. Within a decade, green patches begin to spread where the ground stays moist. Ferns and mosses anchor the soil, followed by liverworts and small shrubs that feed on the nutrients from decomposing remains. The Earth's surface, once black and grey, starts to shimmer with a pale green fuzz. Even the air changes. Photosynthesis returns, pulling carbon dioxide from the atmosphere and releasing oxygen again. The first breath of a living planet begins anew. In the fossil record, this rebirth is visible in fine detail. Charcoal layers give way to sediments rich in pollen and plant fibres. Streams carry spores downstream, depositing them in newly forming lakes. The ash, once toxic, becomes fertile soil as minerals leach out and mix with decayed organic matter. The same elements that destroyed life, sulfur, carbon, nitrogen, now feed it. Nature, as always, recycles its own catastrophe. The animals that survived emerge cautiously into this quiet new world. Mammals leave their burrows under skies that are no longer red but silver. They feed on seeds and roots, digging through the soft ash to find insects returning to the surface. Crocodiles slip back into rivers, now clear enough to reflect the light again. Turtles crawl out of the mud to lay eggs in the damp soil. The silence of extinction begins to break with the faint rustle of movement. Birds, the living descendants of dinosaurs, also return to the open air. Their wings, once singed by the heat of the firestorms, now carry them over landscapes dotted with green. Fossilized droppings from early post-impact layers reveal undigested seeds, proof that these small, resilient birds were already spreading the new plant life. Every seed carried in a beak or claw becomes an act of restoration. Over time, as the atmosphere clears, sunlight strengthens. Temperatures slowly rise, melting the last of the impact winter. Rain falls regularly again, washing away the acids that had poisoned the soil. Rivers carve new paths through the ash plains, and deltas begin to bloom with reeds and algae. The smell of rot fades, replaced by the earthy scent of wet leaves and new growth. The balance is weak. Compared to the lush environments of the Cretaceous, the world is still empty, but its promise is coming back. First cycads show up with the ferns, and then the first blooming plants take back the fields. Fires that used to be there are giving way to forests, though they are smaller and less dense than before. They won't be as great as they used to be for millions of years, but the groundwork has been done. The fern world, as scientists call it, lasts only a few thousand years, yet it's one of the most important chapters in Earth's recovery. Without these early pioneers, the soil would have eroded into the sea, leaving the continents barren. Instead, the ferns stabilized the land and prepared it for forests, grasslands, and the eventual return of complex life. The mammal dawn. After the extinction, there was quiet, and then a new beat started. From the ashes come creatures so small they can hide from doom itself. The age of thunder and scales is over. They have warm bodies, fur, and can change into many different shapes and sizes. They now own the world for the first time in 160 million years. The giants are gone, the woods are thin, and the air still smells faintly of sulfur. They emerge quietly. The first light of morning filters through ferns and moss, revealing movement in the underbrush. Tiny shapes dart from burrows, noses twitching, ears perked. They look unremarkable, creatures the size of mice or rabbits, but they carry within them the blueprint of Earth's next rulers. Their ancestors had lived in secrecy for ages, hiding in shadows, scavenging by night while dinosaurs ruled above. Now, with the predators gone, they rise. In what's now North America, fossil evidence from the early Paleogene shows the explosion of this new life. Within a few thousand years of the asteroid's impact, small mammals multiplied into dozens of species. There were insect eaters like Peripticus, fruit eaters like Dungulatum, and early omnivores with versatile teeth, nature experimenting with new diets and forms. The extinction that wiped out the dinosaurs did not end evolution. It accelerated it. The first generations live cautiously. The nights are long and cold, and the forests thin, but mammals are built for endurance. Their fur keeps them warm. Their rapid metabolisms let them stay active even in the chill. They can dig, climb, and swim. They nurse their young, tiny, fragile things that cling to life in the safety of burrows. Parental care becomes their greatest advantage in a world where survival depends on adaptability, not dominance. In the tropics, as sunlight returns, fruit-bearing plants begin to spread again. Ferns give way to flowering shrubs, and with them come insects, beetles, bees, and ants. The mammals follow. Some grow sharper claws to dig for roots, others longer limbs to leap through the regrowing forests. Fossils from this time show changes happening at breakneck speed. The world that once moved to the slow rhythm of dinosaurs now pulses with smaller, faster life. The sky, too, transforms. The descendants of the smallest feathered dinosaurs, the birds, thrive in the cleared landscapes. But while they rule the air, mammals begin to dominate the ground. In Asia, small primate ancestors swing from thin branches. In South America, early marsupials scurry across riverbanks. In Europe, rodent-like species gnaw seeds and hibernate through cold spells. Every continent becomes an experimental ground for the rebirth of life. Predators return as well, but they are different now. Gone are the reptilian hunters that ruled with teeth and scale. In their place, new forms appear. The first creodonts, wolf-like mammals with shearing jaws, and early mesonychids, carnivorous hoofed animals that will one day give rise to whales. Even without dinosaurs, evolution wastes no time filling the empty throne. For a while, the Earth feels rough and unpredictable, like it's still getting better. The air is still cold, and there isn't much greenery. However, life cycles start to become more stable again. There is more oxygen in the air, rivers are clear, and rain falls clean. It is now locked up in the ground and plants, where it used to be in the sky. The world slowly gets back to normal. It's hard to picture how quiet this morning must have been. There are no thunder lizards shaking the ground or sky giants blocking the sun. Instead, there are soft sounds like chirps, squeaks, and the rustling of plants. The age of adaptability has come to an end, leaving behind the age of titans. Every little survivor, whether it crawls, runs, or climbs, is a new chapter in a story that was almost over. The age that followed. Earth used to be very quiet, but that won't last forever. Over many years, the broken world starts to put itself back together again. Rivers cut through layers of ash and bring new life to the area. Ferns give way to tall green woods. The air gets warmer again. When the sun comes up, the seas, which used to be grey and still, shine blue. From the ones that made it through, the animals, birds, turtles, and crocodiles, evolution starts its next big test. By 1 million years after the asteroid strike, Earth is no longer a wasteland. In North America, tropical rainforests spread across the coasts. Trees return: palms, magnolias, early figs. Fruit becomes abundant and mammals follow, growing larger, stronger, bolder. The descendants of tiny nocturnal creatures now fill every corner of the land. Some burrow, some glide, some climb trees for the first time in history. The fossil record shows this sudden burst of diversity as one of the fastest recoveries in evolution: the Paleocene-Eocene radiation, a biological explosion of forms and colours. Without dinosaurs, no single group dominates. Nature experiments freely. Some mammals stretch their limbs and evolve into early ungulates, creatures that will become horses and deer. Others take to the trees, their hands and eyes adapting for grasping and climbing. From them will come primates. Some venture back into the water, growing sleek and smooth-bodied. Their descendants will one day become whales. The world, once ruled by giants, now belongs to the adaptable. Birds continue the legacy of flight. Freed from competition with pterosaurs, they evolve into hundreds of shapes and sizes: herons, owls, and the first great flightless species that roam the plains like living echoes of the dinosaurs. In the seas, sharks reclaim their ancient dominance, while coral reefs rebuild themselves around new ecosystems. Each ocean current hums with life again. Even plants evolve to fit this new age. Flowering plants, once minor players in the shadow of conifers and cycads, now cover the continents. Pollinators, bees, butterflies, and beetles multiply in response. The planet becomes brighter, greener, more alive. Photosynthesis surges, oxygen levels rise, and the Earth breathes deeply for the first time since the impact. Climate shifts too. The chill of the impact winter fades into a long, warm age. The Paleocene and Eocene epochs bring tropical temperatures from pole to pole. Forests grow in what is now Alaska and Antarctica, home to crocodiles, turtles, and lemur-like mammals. It is an age of warmth, growth, and recovery, a planet-wide rebirth after near-total annihilation. And from that rebirth, intelligence begins its slow ascent. The first primates swing through the canopy, testing memory and coordination. The first cetaceans explore the seas with complex communication. Evolution starts to favour not just strength, but curiosity. Every surviving species is now part of a lineage that leads forward, to elephants, dolphins, and humans. Its influence never really goes away though. The border layer, which is a thin band of iridium-rich clay, is still in the rock. It's like a scar on the planet's surface. It marks the end of one era and the start of a new one. Everything found above it is from the New World, and everything found below it is from the Lost World. It's the best line on Earth between death and life. Even though it's millions of years afterward, we can still see the effects. The animals that turned into humans were shaped by the woods that grew from ash after the dinosaurs died out. Everything else could start to grow. There is a heritage of life written in the DNA of every bird in the sky, every animal on the ground, and every tree that lifts its leaves to the sun. The Earth broke apart and then put itself back together again, showing that even the worst ends can lead to new starts. Some dinosaurs are no longer with us, but their memory lives on in every bird, tree, and living thing that came out of the ground. That day, the world didn't end, it changed. If you found this trip through the last hours of the dinosaurs as scary and interesting as we did, please like and subscribe. Come with us as we explore more lost worlds that shape the world we live in now.